Hello, welcome back 11th standard students to chapter 1 sets. Next definition we are going to see equal sets. From the name itself you can understand equal means if we take two sets, every element A and B, every element of A is also an element of B, and similarly every element of B is also an element of A. Then the sets A and B are said to be equal, isn't it? So this is the definition. This is how it goes. Suppose I take A equal to 1 comma 2 and b equal to 2 comma 1. Okay, I take a definition like this. Okay, now we can say that a equal to b. Here also we have got 1 comma 2, here also we have got 2 comma 1, but even though the order is changed, they are the same element. So we can say a equal to, we have already seen a note that order is immortal, isn't it? So we need not worry about the order. We have to see only if the elements are there. Here also 1 is here also 1 is here also 2 is here, and here also 2 is here. So if we get like this, then we can say A is equal to B. And one more note here, a set does not change if one or more elements of the set are repeated. So we'll take the same set. Suppose A equal to 1 comma 2, and suppose B equal to, I get like this, 1 comma 1 comma 1, 2 comma 2 comma 2. Even though the elements are repeated, what are the actual elements in B? It is actually 1 and 2, isn't it? And A also it is 1 and 2. So can we say A equal to B? Automatically we can say A is equal to B. This is the reason why we do not repeat the elements in a set, isn't it? We'll take it more clearly with this example from your book. Which of the following pairs of sets are equal? Justify your answer. Okay. So the first one, they are given, always it will be given, if it is given in set builder form, you have to automatically change it into roster form before answering any question, because in set builder form we cannot find the elements, how many elements are there, are the elements are repeating or not, all those conditions we cannot see. So always when you solve a question in sets, if it is given in set builder form, automatically you have to convert it into roster form, and then only you have to answer the question. So the first question, X is a set of letters in alloy. What are the letters in alloy? What is repeated? L is repeated twice. So I will get it as A, L, O, Y. Okay. And one more set B in the set of letters in loyal. In this also L is repeated. So what will be that? L, O, Y, A. Now see, the order is repeated, but here also I have got A, here also I got A, here also I have got L, here also I got L, here also I got O, here also O, and here also Y, and here also Y. So all the letters, even though their order is changed, there are 4 letters in X and 4 letters in B. So we can tell X is equal to B. So in the first sum, they are equal. Okay, X and B are equal. What about the second one? When you take the second one, set A, n belongs to Z. What do you mean by n belongs to Z? It is -2, -1, 0, 1, 2, and so on. Isn't it? Here also you will have dots, here also you will have dots. And what is one more condition given? N square equal to 4. So where n belongs to Z means, suppose I take it is 4, is less than or equal to 4. So it can be n square can be equal to 4 or less than 4, two conditions. Okay. So now I will take, what will you get when you square a number? When will you get 4? When you square 2 only you will get 4. When you square 3, it will become 9, which is greater than 4. So 3 does not belong, -3 or +3 does not belong to this set. So we are going to consider only from -2. Okay. So when you take n equal to -2, so n square equal to -2 the whole square, which is equal to 4, which applies to the condition less than or equal to 4. Next I am going to take n equal to -1. Again -1 the whole square, which is equal to 1, which is less than or equal to 4. And the same condition applies when n is equal to 2 and n is equal to 1 also. You are going to get the answer as 4 and 1. So what will be your set A? A will be -2, -1, 0 also applies, isn't it? When you put 0, it is 0 square is 0, so 0 is less than 4, and 1 and 2. So these are the elements in A. Now we'll come to the question. They are asking whether A and one more set is B, isn't it? What is B? What they have given in B? X belongs to R, solution of x square minus 3x plus 2 equal to 0. So what will be the solution set for this? 2 into 1, isn't it? So you will get minus 3. When you factorize, it is like this. So minus 2 minus 1. 2 into 1 will give you plus 2 and 2 plus 1 will give you 3. So you will get it as x square minus 2x minus x plus 2 equal to 0. Taking the common terms, x minus 2 minus 1 into x minus 2 equal to 0. So it will become as x minus 1 into x minus 2 equal to 0. Therefore the values of x is 1 and the value of x is 2. So your set B is going to be 1 comma 2. Okay. So what is set A? Minus 2, minus 1, 0, 1 and 2. And what is your set B? 1 comma 2. So now are these sets equal? No, they are not equal. When they ask you justify, you have to justify why they are not equal. Now you see here you have got only 2 elements, whereas here you have to take 0. 0 belongs to A, but 0 does not belongs to B. Therefore A and B are not equal sets. So this is how you have to answer. When they ask justify, you have to give the reason why you are saying A and B are not equal. I think with these 2 examples, equal sets will be very clearly understood for you students. Practice the sums also in your book. Okay, thank you.